All right, so my name is Dan Kittredge. I'm a farmer from Massachusetts. I grew up on a homestead, organic farm. My parents bought 30 acres on a dirt road in 1980 and built a passive solar house and root cellar, milk cow, chickens, put in the fruit trees, the whole thing. We started our local farmers market in town in '85, I think, or something like that. My parents were helped write some of the first organic certification standards in the country for NOFA. We had a CSA in '91. I've been doing this farming thing for a while. What put me on this path specifically that I'm on now was when I got married and realized that even though I had grown up on an organic farm, been doing it all my life, and that was, didn't really have the skills to do it professionally. I couldn't make a living. I was good at working long hours and hard, but not good at making any money. And so I got to thinking about things, and I've been studying and practicing for the past 10 or 12 years, and have come to a point now where my wife and I, we have a 24-acre farm in central Massachusetts. We do about 2.5 acres of vegetables, half an acre of that is hoop houses. We do plus or minus 15 acres of pasture for pastured poultry and grass-fed beef. And I like to say I make my living working 20 hours a week on the farm, which gives me time to bop around the country and blow my mouth off like I'm doing now. So, my parents, were not able to make a living farming. They had a professional career, which is managing their local organic farming organization. If anybody's ever heard of NOFA, Northeast Organic Farming Association, Natural Farmer, NOFA Summer Conference, that's stuff that they've been intimately involved with for 30 years, plus or minus. So, as I was saying, when I was started to take responsibility for actually making a living and started to think about organic and everything I've been taught and brought up with, I had to come to terms with some basic rudimentary facts. I like to tell the story of when I was out checking on our old farm dog Stewball, who had just a few days prior been run over by a CSA member on the driveway. He was getting old, and he was laying in the driveway sunning himself, and somebody whipped in and just drove over his rear end and grounded into the driveway, and he yelped, and they stopped and apologized, and no bones were broken, so we got to hang out in the house for a couple days, and then we went back outside. So he was out laying on the driveway, and I was checking on him to see how he was doing, and there was a spot where his skin had been cut, and I was just checking it, and there was maggots in there. Flies had laid eggs, and the eggs had hatched, and there was maggots eating his hind end, which caused me to about retch. There was an aha moment in there somewhere when I realized that I had a 5-gallon bucket, and I was going over to the potato plants to knock off potato bugs, because we had to do that every 2 days to keep the plants from dying too fast. And I was like, so if there's larvae eating my dog alive, and I think that's repulsive, why do I not think it's repulsive that there's larvae eating my plants alive? In fact, I consider it to be totally normal that there's larvae eating my plants alive. If I was raising chickens and they were being eaten alive by a flesh-eating fungus, they had a systemic staph infection, they're being eaten alive by a systemic staph infection, I would probably consider that to be something wrong. I probably wouldn't slaughter those chickens in good conscience and sell them to my customers or feed them to my children. And yet, every year I pick cucumbers that are being eaten alive by a flesh-eating fungus. I pick squashes being eaten alive by a flesh-eating fungus, and I consider it to be totally normal. So my basic thought was that perhaps even though, I had my nose pretty far up in the air because I was organic and other people weren't, maybe that wasn't the be-all and end-all. Maybe there was more to it. And maybe if I was able to grow plants that were healthy, I'd be able to make a living, which is really the driving question here, because I grew up on a farm where I worked all the time, and while I like farming, I don't really like working all the time. I've done enough of that. I like to have a little more peacefulness in my life. So I started reading books and going to conferences and taking seminars and practicing on my parents' farm, and then I got a job managing somebody else's farm, and finally we have our own farm now. What I found is that if you create the environment, at least even sort of well, not do a great job, just do some basic rudimentary things well, your plants actually do better, and healthier plants means better yields, means better pest and disease resistance, means better flavor, means you're sequestering carbon in the soil, means nutrient levels are higher, which means the people who eat the food are actually being healed by your food. So as I've started to put all these pieces together, and understanding that I came from the organic community with 30 years of experience and I hadn't heard about any of this stuff, I thought maybe other people hadn't also. And so I started giving workshops, and those turned into courses, and that turned into an organization, and now we've got a whole thing going on around the country, which is kind of exciting, which I plan to get into at least in short after lunch. But that's my quick background, quick introduction, not quick actually, sorry for belaboring it, but we all like to talk about ourselves. So it should give you some perspective at least about what I can and can't offer. But I really want to know what you guys are curious about, what you're struggling with, what you have questions about, and then we'll just jump into it.
We have some property that we've been working with for 20 years or so, and we just did soil samples, and they're doing pretty good. But we've got another farm now that we're starting on, and we're trying to find out how can we make, instead of it taking 20 years, how can we do it faster?
Yeah. Yeah, as efficiently as possible, as inexpensively as possible. What do they say? My brother's a contractor. He says you got 3 things to choose from: quick, cheap, and good. And you can have any 2 of the 3. So I'm not sure that's quite true, but yeah. Yeah.
Well, we have lots of resources in this area, including Living Web Farms, Organic Grower School, and so forth.
Yeah.
And so I was intrigued by the title Nutrition Dance for Nutrition, because I was thinking, gee, what am I growing already? So I think, to me, it's like, what's different from what other people have offered or explained?
That's a really good topic, maybe just to start on. Yeah, actually, I can use that with my first slide. Yeah.
I had one more, really, why I signed up before. I talked to you guys several years ago because we were getting ready to start, well, now it's turned into a biodynamic farm down in Lower South Carolina.
Yeah.
And you have all those wonderful products and at good prices, but have you worked on any way to ship those further south at a better rate? Because at that time I was wanting to order some stuff, and it was going to cost me more to ship it down here than the actual product would have cost.
Perfect. That's a great practical question. Yes. The answer is yes. Yep.
So one of our issues is going to be, we've done intensive grazing for a long time, and we know how that's going to transform land over time.
Yeah.
But the 50 acres we're working on right now has been in really bad condition, so we're thinking on the large scale. Like I can't go out and pour amendments onto my 50 acres very easily.
Yeah.
So just put in pasture.
Amending pasture, amending pasture. Yeah, I will probably err on the side of talking about annuals, but the principles generally apply. Most people generally have annuals in common and aren't necessarily doing animals or fruit trees or things like that. But they're totally, yes. Well, feel free to remind me and whenever you want as well. I will try to, yes.
Okay, so I got kind of like big picture questions.
Shoot.
One is, one of the most popular speakers we brought in was Dr. Elaine Ingham.
Yeah.
She basically says everything you need is right there.
Yeah.
Get the biology right, you got it all. So I want to see if you can integrate that, because I think I'm hearing you talking about supplements. And then the other piece is, and I had the perfect example this spring. Spring, as we looked at our garlic for the first time in our experience, doing very poorly because we didn't have intensive winter rains, which is what controls the leaf curl mite. So, I've only very briefly heard what you say about, if you have insects, it's because you're growing food that insects want. And do you recognize that there are conditions sometimes where that is not necessarily the case, where the plant is adapted, and then there's things that throw it off besides mineral imbalances?
Okay, those are both good. Anything else? You guys ready? We're ready. All right. Principles of Biological Systems is the name I've evolved for this conversation. By biological systems, my general thought is that we're working with life, and there's some really beautiful, simple, elegant patterns and systems that life seems to have developed. And I think in many cases, the information we've been taught has been framed in a much more reductionist, mechanistic kind of manner. We've been taught about chemistry here and about physics over here and about biology over there, but we haven't really integrated all the pieces of the puzzle from the lens of life. And I would say that, as a culture, we're living in this sort of mechanistic paradigm. Everything is framed as pieces of the puzzle, and reality is we're living in life. I think life is actually the dominant paradigm. And so if I can accomplish one thing in the next 2 days, I'd like it to be helping you have a more integrated comfort with an understanding of what life is and how it works and what it needs. You see there in the first slide my email and phone number. If you would like to contact me, those are the best ways to do it. The term bionutrient we coined, I think it was like 7 or 8 years ago, to refer to those compounds in food that correlate with flavor and aroma. When I started first learning about these principles of biological systems and how they all worked and understanding the difference in nutrient levels in food, I was asking the people I was learning from, why is no one talking about this? If this is true, why is no one talking about it? Has anybody ever eaten a calorganic carrot? Anybody here had a calorganic carrot? Have you had that experience in your mouth of a somewhat bitter or almost like a soapy flavor? You know what I'm talking about? Yeah. Has anybody here ever eaten a carrot out of the garden or out of the farmer's market that had an entirely different flavor? Yeah. Right. Do you know what it is that causes one carrot to taste soapy or bitter and one carrot to taste carroty?
No. The nutrients.
It is that exactly which is that determines the quality of the crop. The USDA has been monitoring average nutrient levels in crops since the 1930s, right? Milligrams of calcium per 100 grams of broccoli, et cetera, et cetera, et cetera, et cetera, et cetera, et cetera, et cetera. In general, for what it's worth, this has been the trajectory of average nutrient levels in crops since the USDA has been monitoring them since the 1930s. Of course, there is no average crop, right? There is no average carrot or average broccoli. So they will take 9 heads of broccoli from, different parts of the country, send them to a lab, put them through their machinery, get the averages and publish it. And that's the USDA average. That's what we assume broccoli contains. The average has been dropping, but there is no average. So my thought is that, actually, we are hardwired as animals with a very sophisticated nutrient monitoring device. People say that we've lost our instinct. Anybody ever heard that one? We're humans, but we're animals, but we've lost our instincts. That's baloney. That's not true, right? We're totally hardwired with a very sophisticated, monitoring devices. We'll talk a lot more about the subtler aspects of it all tomorrow, but I would suggest, I think actually the scientists say that there's 30% of your DNA, 30% of your DNA is involved with the function of your nose and your tongue. 30%, which is, that's a lot of, that's a lot of computing power or whatever DNA is. My understanding is that which makes a carrot have a nice carroty flavors is it's a carotenoid, it's a secondary metabolite, it's a complex compound that's built in a plant only after the lipids and the fats and oils have been built, which are built only after the proteins and all the amino acids are present, which is built only after the carbohydrates are there and all the enzymes. So when you've got a food, a natural, whole food that has this nice flavor, that means it's got a whole bunch of other goodies in it. That means that's how we have evolved to discern what we should eat and what we shouldn't eat, is with this really sophisticated nutrient monitoring device called our tongue. You can find organic carrots that don't taste good, which means they aren't good for you. It's really, really, really rudimentary. They may be less toxic than conventionally farmed carrots, but they're not necessarily more nutritious. I would suggest a lot of the food that we have available, local or not, organic or not, biodynamic or not, permaculture or not, whatever your label is you want to associate, doesn't necessarily taste good. Anybody ever had chard that left like a skin in their teeth? Or spinach? You ever had that experience of eating spinach? You're like, I know it's good for me, but you're an animal. Don't let what someone tells you weigh what your body's telling you. On some really rudimentary level, we know already, and we're not listening to it. So I would suggest, this is, this is what I have chosen to focus on as an entry point into a broader conversation. As I began to learn about these things and understand the correlations, let me just do a couple more sort of basic ideas here. If there was a bale of hay in here, when you walked in, would any of you have considered eating it? No. Would you have considered sitting on it? Sure. Entirely possible. If a cow walked in, would she have considered sitting on it? No. Would she have considered eating it? No. If it was a good bale of hay, if it didn't get rained on while it was down before it got baled up. Why is it food for a cow and not food for a human?
Well, stomachs.
Cows have 4 stomachs. We don't. They can digest things we can't. Complicated? Not complicated. We all know this. Different organisms have different levels of digestive system capacity, functional. Different organisms can digest different things. The Colorado potato beetle larvae I was referring to before, you may not know, does not have the alimentary canal we have. They do not have livers. They do not have the enzymes in their gut necessary to break down protein. Protein is only one compound on the way to building lipids, which are on the way to building secondary metabolites. When you have a potato plant, which is actually able to build the higher order compounds which correlate with flavor and aroma, it is technically indigestible to a Colorado potato beetle. Fungal hyphae, have only a certain digestive system function, which is less sophisticated than ours. When you have crops that actually taste good, they actually biochemically are indigestible to bacteria, fungi, insects. I would say that nature is giving you a report card, whether you want to listen or not. She is telling you who these plants you're growing are fit for. If they're fit for insects to eat, insects will eat them. If they're fit for fungus to eat, fungus will eat them. If they're fit for animals to eat, animals will eat them. Only when you have animals as your pests are you growing animal food. If you have insects as your pests, you're growing insect food. Nature is really blatant, and we are stuck in our heads, and we are in this, us, them, fight, power, control, respond to the symptom, not the cause, sort of ridiculous mentality. We need to stand back for a second and understand that it's really elegant and really beautiful. Where in nature do you see monocultures? Where in nature do you see bare soil? Who's adding fertilizer in nature? Who's starting seeds in potting soil, in little trays? And I would suggest that if we figure out how to work more well with nature, actually, our things work more well. I would suggest that there was a form of agriculture being practiced here 500 years ago, which was a very, very, very sophisticated form of agriculture. As I understand it, the humans that were here managed from ocean to ocean with no plow, with no wheel, with no beasts of burden. There was more beef being produced in the Midwest 500 years ago than there is now, right? How many pounds of beef are being produced by corn and soy and tractors and machinery and chemicals? Literally, the Native Americans were producing more meat in that same amount of space, right? Literally, the fishes were jumping out of the rivers. The forests were full of nuts and berries and roots. Literally, the landscape was being managed in a much, much, much more sophisticated manner. So I think we've got a lot to learn. If we could start with humility, we maybe can go somewhere. If you think you got it all figured out, then I can't help you, right? I'm just some random kid from Massachusetts, some damn Yankee. Why would you listen to me?
Stuck by that amazing thought that you just said about if the plants are healthy, the insects won't be attracted.
They physically can't digest them, and they can't see them also, but yeah.
Because I just remember I had this beautiful basil, all over, our garden, and it looked healthy and beautiful and
right.
Smelled good and everything. And we got invaded by Japanese beetles, and they just decimated it.
Yeah.
But if I had to go by my smell and taste, it seemed good to me. So I'm not trying to challenge you because I do believe.
Feel free to challenge me. That's fine. No, good, healthy conversation is always good.
I just, you know, if it seems beautiful and healthy to us, I can't imagine it wouldn't seem healthy and beautiful to a beetle or some other.
The beetles are the ones who have the most sophisticated digestive systems, from the bacteria to the larvae through the fungi. The beetles are the, you know, the last ones that you're going to get resistance to before you have only animals eating your crops. We had this experience a couple of years ago when something called late blight came up from down south. You guys heard about this late blight thing? The classic refrain was, "My tomatoes were so healthy, and then they were dead." If you think the pre-dead state is healthy, then you need to redefine your understandings. Right? Things don't just go from healthy to dead. There's a whole continuum there. I mean, just maybe I can use late blight as an example because this was 2009, I think, and I knew enough at that point in time to be able to not be afraid and say, look, it's just a pathogen, just like all kinds of other pathogens. It's only when the host is susceptible can the pathogen infest. We have this whole germ theory thing. Hear about germ theory? Such a silly idea, right? Louis Pasteur proposed germ theory, that these germs are what cause disease. Has anybody ever been in a room for an hour and a half or say a day when somebody's coughing and sniffling? Like, you understand the idea of germ theory is that if they're coughing and sniffling, their germs are going to be all over the room and you're going to get them. So if germ theory was true, then you would get sick. But you know you don't always get sick when there's somebody in the room coughing and sniffling. Only sometimes you do. Yes? Yes. Then therefore, germ theory is not true. Pasteur had a contemporary whose name was Beauchamp, Antoine Beauchamp. And Beauchamp proposed what's called biological terrain. I'm not sure how he said it in French. He said it was the terrain, the biological terrain, which determined the susceptibility of the host. When your immune system is weak, then you're susceptible, then the germ can infest you. But the presence of the germ by itself is not enough to ensure that you're going to get sick. So I'm not afraid of late blight on principle. I'm not afraid of late blight. Like, I love late blight, actually, because it means a lot of my competition loses their crops, which means I get more money. So I'm a big fan of late blight.
So you did not experience late blight. Did you have nearby cases?
So what happened on our farm? Let me give you just a case study on our farm. So everybody was all worked up. So, you know, I mean, UMass was telling people to take big trash bags and drop them over the plants and zip tie them and cut them off and take them to the dump. And I'm like, do you guys not understand how spores work? 500 million spores. You're going to drop a trash bag over a plant, you're going to take all the twine off, and ridiculous, fear-based, anyway. So, for summer conference, it was a panel. I had somebody from Cornell, somebody from UMass. I think Paul Stamets was there. I was on the panel. I took a picture of my tomato plants the day before. This is the middle of August. I said, here's my tomato plants yesterday. I haven't sprayed anything on them. We don't have any late blight. Like, oh, the late blight flew over your house. Everybody else got it, but you didn't get it. I'm like, okay. So I grew those plants out. They, had a productive year. End of September, beginning of October, I was starting to get down to the mid-30s at night, and I got late blight. The late blight was on my tomato plants. I saw it there. I took those tomato plants, and I pulled them out, and I stuck them in my hoop house because I wanted to keep that late blight on my property so I could give it to my tomato plants next year so I could take it away from them, because I'm not afraid of a little bit of disease. There's nothing to be afraid of. So I did. So I put my salad greens in, planted my salad greens, tomato plants from the edges, the dead ones. When they got done with the greens in the spring, put my new tomato plants in, seedlings, and then I just didn't water them. I just let them suffer. I wanted to get them sick. So I stressed them out. Took like a month. Finally, I had a good solid case of late blight. I had 3, 4, 5% of the plants were dead. Another 10, 20% were losing their arms. I'm like, all right, I got late blight now. So I fed them. I just gave them food. And foliar sprays, nutrient drenches, things like that, inoculants. 10 days, late blight was gone. 100% gone. My understanding is that we have this really perverse relationship where we don't understand that plants have a lot in common with animals. Think about a tomato plant. Think about a 2.5-foot tall tomato plant. All right, she's probably flowered, might have set fruit. If that was a human, where would she be in her life cycle?
Puberty or beyond?
Just past puberty. She's a pregnant 13-year-old. She just became reproductively viable. She hasn't built her adult body yet, and she's knocked up. She needs to be fed really well if you want her to have healthy babies and a long, healthy life. You need to take care of her. You need to feed her. You need to make sure she's got everything she needs. Anybody heard about this calcium thing? Like when a woman's pregnant and she doesn't get enough calcium in her diet, then she'll suck it out of her bones to put it into her baby. You heard about this one? Plants do the same thing. When your plants aren't being fed well enough and they're pregnant, they're going to suck the life force out of their body to feed their babies, and they're going to die because of it. And you call it a disease, and I call it bad parenting. Right? You are doing a bad job giving them what they need to flourish. Take responsibility for it. Right? It's really simple. Birth, colostrum, germination, inoculation. Early childhood development, seedlings. Like the pattern across the life cycle is really simple. It's really simple. Once you understand life, you understand life. So I'm going to be going back and forth from animals to plants. In almost all cases, the science is showing us that the dynamics are the same. There's a couple different ones. I think animals have pituitary glands and plants don't, which means plants' growth is not regulated by time when animals is. But I mean, there's a couple minor differences, but otherwise it's really remarkably similar. And so that's the frame. Yeah.
I can't really remember exactly how this worked, but chlorophyll and blood are very...
The same compound. One has a magnesium in the center, one has an iron at the center. It's the same exact compound. Exactly. The biochemistry, the enzyme systems, the whole symbiotic dynamics, the ecosystem function with the gut flora, it is absolutely similar. Humans have been doing a good job working with life for a long time, right? We have long track records of humans in different parts of the world having really healthy relationships with life, and we don't in this culture. And that's not because we don't have enough science, right? Humans, for a long time, have been able to do well with life because they've understood life. I think we've got too much science. We're in this reductionist, mechanistic, totally like wonked out in our head. This piece is here and that piece is there, and this person said that. I read this book over here, and I don't know what I'm doing. It's really simple and elegant, and you should be able to figure it all out. So I hope to leave you with some, feelings of empowerment and confidence, and trust your intuition and all that kind of stuff. So there's some opening comments. I'm sure we'll get to some of these points. All right, let me just, I got to do this. Someone just get it over with. Most plants are green. Everybody's okay with that statement? Because of the chlorophyll. They cover their bodies in chlorophyll, which is this compound which uses carbon dioxide and water and sunlight to make sugar and oxygen. Everybody's heard about this one? Photosynthesis. CO2 plus H2O plus sunlight. We know that plants take the oxygen they manufacture and they kick it out of their leaves into the atmosphere. What many people don't know is that a healthy plant, and this is the caveat, healthy plants take a majority of the sugar they manufacture in their leaves, and they bring it down through the stem into the roots, and they literally inject it into the soil. So healthy plants, all plants cover their bodies in green. Healthy plants take that stuff that they make with that which they've covered their body with, and they kick it out of their body. So nature thinks it's really important for plants to cover themselves in green and then to eject that which is manufactured into the atmosphere, into the soil. What's the deal? If the whole, I'm going to operate with a basic, a couple dogmatic statements, like nature knows what she's doing. Like I'm just going to sit with that one, and you can argue with me all day long, and I'm not going to change my mind. I think nature's got a few things figured out, and it would be in our best interest to understand what she's got figured out. So the entry point into this broader conversation is, what's the deal? And it's not that complicated. I think the scientists have, teased out enough of these pieces that we can say with some significant confidence. The deal is that in nature, nobody's adding fertilizer. Plants have been able to take care of their own business for quite some time before God invented farmers, right? There was a long period of time which plants had figured out how to take care of themselves before God invented farmers, before God invented fertilizer. Plants have evolved the functional capacity to feed themselves. And my suggestion is, if you can create that environment in your growing area, then what you're going to experience is you're going to have lower input costs, less effort, less disease, healthier plants, more productivity, lower cost of production, better economic viability. There's like an octuple bottom line, right? We're getting all these things we think like, well, we can't have everything. Maybe I'll just get this, but I can't have this and this and this if I get this. No, actually, when you work in harmony with life, it all comes together. This is my dogma. Okay, so basically, the deal is that plants, like us, cannot digest their food. Everybody knows about how thoroughly incapable of digesting your food you are if you identify yourself as a human, which is another not quite right statement, right? What percentage of the cells in your body are human? Anybody?
40 or something?
I thought it was 10, then somebody told me it was 40. Now it's like, somebody said it's 1 or 2%. Whatever it is, most of the cells in your body are not human. A vast majority of the cells in your body, in this body that you carry around, are not human. You are not a human, you are an ecosystem. We have this idea about the plants being over here and the animals being up there and the fungi are over here and the bacteria are down there. This is the reductionist, mechanistic, fraudulent paradigm. Actually, they're all totally critically, synergistically interrelated. And only when you can deal with that and create that environment should you expect to have the benefits of vitality and vigor and deeper connection, etc. So foundationally, animals have internal digestive tracts and plants have external digestive tracts, but either way, they critically need bacteria and fungi to digest their food for them, and as we critically need bacteria and fungi to digest our food for us. So what's happening is the plant is making the sugar in the leaf, injecting it down into the soil to feed the soil life, along with various little compounds, amino acids and things, doesn't really matter. They attach to the sugar, and it's called a plant root exudate. And different species of bacteria and fungi have different, they like to eat different things. Chickens like to eat something different than pigs like to eat or whatever. So, and they have different functional capacities, like chickens have different skills than pigs have. They can do different things. So when the plant says, I need copper, it makes a plant root exudate for copper solubilizers, and it feeds it, injects it into the soil, they eat it, reproduce, go about their merry lives, die, and the plant sucks up their juice. 2 hours later, it has gotten a beautiful organic compound that provides its biochemical needs from the sugar that it injected into the soil a little while ago. So it's a virtuous circle. The more the plant grows and feeds the soil life, the more the soil life grows and feeds the plant. The more the plant grows and feeds, it's a beautiful, synergistic, virtuous circle if you can create that reality. So foundationally, my comment is, I don't care what kind of plants you're growing. I don't care if it's grass, I don't care if it's trees, I don't care if it's herbs, I don't care if it's vegetables. From a foundational standpoint, it's only when the people at the bottom of the food chain are happy that anybody's going to function. And most of us are doing some pretty stupid things to kill off the people at the bottom of the food chain, and that's why we're having struggles. It doesn't really matter what we're growing. What's that? Oh, he's talking outside. Thought somebody was mumbling in the back. Oh. Can't be true. Corn needs something different than apples. Feel free to push back if and when you'd like. Yes?
That's actually an interesting point that you just made, because the way that they teach it in schools now is that, grass or plants are the bottom of the food chain. Yeah. But you're talking about going down one level further. Yeah.
If they teach in school the plants are the bottom of the food chain, that shows how bad of an idea it is to put your kids in school. Right? I mean, that is a most ridiculous, ignorant, totally unscientific statement. It's not even funny. It's not even funny. Anybody heard of the Grand Banks? Anybody heard of the Grand Banks? No? There's some spot up off the coast of Maine somewhere. All the fishermen from Newfoundland to New Jersey, they all drive their boats to the same spot to park to go fishing. Heard about this? Some people have heard about it. Other people haven't. It's called the Grand Banks. Do you know why all those fishermen from all those different spots drive to the same spot to go fishing? That's where the fish are. Do you know why all the fish are there? Because all the food for the fish is there. And why is all the food for the fish there? Because we have the right mix of sunlight and warmth and minerals. Only where you have the critical environmental conditions for the bottom of the food chain to function and flourish, should you expect the top of the food chain to flourish. It is, I mean, for me, this is one of the key pieces of understanding here, is that it's about the bottom of the food chain. And when you can create the environment where they can flourish, you should be able to stand back and do a hell of a lot less work. It's really kind of exciting. So it's about creating the environment for the bottom of the food chain to flourish. So this is what the whole course is about, is what are the critical environmental conditions necessary for the bottom of the food chain to flourish? What do they need? And then we'll, as I go through them, we say, this is how you get this one, this is how you get that one. You can think about, oh, this is something I haven't been doing. Oh, maybe this is where my shortcoming is. Because I know I'm doing like 90% of the things right, but still things aren't working. Right? In most cases, people are doing a lot of the right things, but you miss one critical thing, like air to breathe. Right? How well would your children do, or your dog, without air to breathe for just a couple days? Your soil life needs air to breathe. How well would you do without water to drink? Ever had chickens, cows, children? Just don't water them for a week. It's all right. It'll toughen them up. It's only been dry for a week. They're dead. They're dead. Genocide. The bottom of the food chain, when they die off, the whole thing falls apart. Anybody ever grown zucchini plants? Zucchini plants? How many people know about zucchini plants? What? You know that, I'm not sure when it exactly is down here, but I don't know, middle of May maybe? Beginning of May, when they're looking real sexy. They're like real just growing and shiny and like looking good. And then, I mean, for us, it's the end of June, because we can't plant till June 1st, because that's when the frost stops. But end of June, they're looking pretty good. They're growing vigorously. They get nice shiny leaves. Then July comes and the dry comes. Doesn't get, clouds go away, no rain. Week of hot and dry, and all of a sudden they aren't looking so shiny anymore. And then they start to look not just not shiny, but not green. And then they start to look definitely other colors. And then they look dead. Does anybody know what that shine is on a leaf that makes it look? It's fat. It's wax, exactly, the waxy cuticle. So some plants have a thick waxy layer, and some plants have a thin waxy layer. And you can tell that by looking at the leaves and seeing how shiny they are. Plants have this really interesting thing they do, which is that when they get more food to eat than they need, they stockpile the extra food in the form of fat. Anybody heard of that idea before? No. No one's heard of that idea before. So for me, when a zucchini plant is fat and happy, it's got a nice shine on its leaf. Tomato plant, pepper plant, cucumber plant, grass, fruit trees, when they have that nice shine on them, children, cows, right? A cow's got a nice sheen on its coat, you know it's doing well. When that sheen goes away, it's got a dull colored coat, you know something's wrong with the cow. What happens for us when it gets hot and dry for a week, as I understand it, is it hasn't rained and the soil dries out. And when the soil dries out, the soil life dies. When the soil life dies, they stop feeding the plant. When the plant stops being fed, it starts to eat up its fat reserves. When it eats up its fat reserves, that sheen goes off the leaf. Does that make sense? It's a water deficiency. People think they're watering the plant. No. You need to water the life in the soil. The life in the soil must have water to drink everywhere. You can't just have the water right here underneath the plant, because all these guys everywhere else are going to die. They're going to be dead. There's no water, there's no life. Foundationally, it's the bottom of the food chain. It's this beautiful, synergistic, mycorrhizal, fungal, beautiful ecosystem that is the foundation of healthy plants. And if you manage your soil in such a manner as to keep it wet right underneath the plant and dry for, a bunch of space in between, you are, systematically taking out 80% of life, right? That plant is operating with 20% or whatever of the capacity it should be able to have because you haven't kept the soil moist. So critical environmental conditions, air is critical, water is critical, food, soil life must have food to eat. The life itself must be there. In many cases, the species we need are not present. And I like to talk about minerals, which people accuse me of that being the only thing I talk about. I think it's a piece of the puzzle. It's one of the things that I learned about that I hadn't heard about before in the organic world. There were a couple of the questions that came up today sort of inferring that was all I talk about. Please, that is a piece of the puzzle. It is a critical piece of the puzzle, but these other ones are also extremely, extremely important. Is that a question?
I think you'll get to. I was just going to ask, what do you consider food for the soil?
Yes, exactly. Great.
Prior to asking the question, I want to emphasize everything you say I agree with.
John thinks I'm right. So that's good with something.
My only concern is just to use your analogy of the, out in the sea, that area with the coral reef or whatever.
Yeah.
It doesn't have every type of fish in the ocean there, right? Mm-hmm. There's not big whales there. There's whales there. Well, there may be whales there, but whatever it is, it's not every type. It's not going to be tropical and cold. And so what we're doing in vegetable garden production a lot of times isn't found in nature. It's, in nature you don't have where blueberries and potatoes grow the same place as cucumbers are naturally found there. Like, there's a lot of factors. And so in a sense, with cultivars and with different types of varieties, all these different things to try to have that environment, in a sense, do you agree with the idea that that's not natural? And so when the goal, it almost seems like you're trying to find this medium that they all kind of can do somewhat decent in. So say 6.5 to 6.7, and it has this and it has that. So you're creating this thing, but it's almost like it's not really ideal for them. It's not, some are light feeders, some are heavy feeders. It's this like dance that we're playing basically.
I think I know where you're going with that question. For starters, I think I said this before, where in nature do you see monocultures?
No, I agree.
You don't see monocultures. Right. So one of the wisdoms from the permaculture community is this whole guild thing. Mm-hmm. And that there's certain families of plants that like to live with each other and are synergistic. The point you're making is we're bringing in plants that are endemic to Asia and to South America and to Africa and trying to plant them all together. Is that the point you're making? And they don't all necessarily grow well together,
almost
or
like there's a one-size-fits-all biology approach.
So my thought is that life needs these basic critical environmental conditions to exist, and the plants feed the species that they need. But all the species need these basic environmental conditions. We can talk about blueberries if you want with pH, because this is one of my classic. I love to just sort of blow that one out of the water. It's wrong.
I don't want to misunderstand. pH is just one concept, but just use the lake life for example.
Well, not heavy feeders. You said heavy feeders too.
Yeah, like the idea of growing brandywine in Western North Carolina.
Yeah.
I'd like to imagine it's possible to do that without getting but it just seems
really, that's how low the bar is?
What is it?
That's how low the bar is? That you think it's not possible?
It's not that I think it's not possible.
No one can do it. No one's doing it.
My experience has led me to believe it's very difficult.
There's a couple ladies right here who seem to be pulling it off.
You don't get lake light?
No.
Okay.
That's for sissies.
There we go.
Humility is a foundational piece of this puzzle. I grew up on an organic farm, and I knew I was a better person because I was an organic farmer, right? It was never questioned in my mind that we were better people.
What happened when you found out differently?
I was able to be humble and work towards, adulthood and maturity and things like that. A lot of us, have our noses a little too far up in the air, think we're God's greatest gift, and we're actually arrogant and, ignorant. And nature's telling us, but we're not listening. If you have animals eating your plants, that is nature giving you an A. If you have beetles, that's a B. If you got fungus, that's a C. If you got larvae, that's a D. If you got bacteria, that's an F. Just a ballpark. Nature is giving you a report card if your objective is to grow food for animals. If your objective is to grow spinach and pigweed is growing better, then you should, in good conscience, harvest the pigweed because it's more nutritious to feed to the animals, the humans. If you're doing a good job in your soil, if you want to grow spinach, the spinach should be out-competing the pigweed. This was a revolution for me, was when my carrots started out-competing the weeds. When I broadcast salad greens, 4-foot wide bed, broadcast a seed onto the bed, I don't see any weeds until after I've picked the greens because the weeds are down below the crown at ground level because they got totally out-competed by my crops. When you create the environment for the things you're trying to grow, they will out-compete the things that are, you know, I mean, I'm sure I'm getting some head spinning. I'm pretty sure I can see some head spinning. And I'm making some grand, massive claims. So, you know, I can explain the science behind any of this if you want. I can say, come to my farm and you can see it in action. And I can also say, don't take my word for anything. You know, if it's true, it'll work. If you think it maybe is possible, find a little corner and experiment. Don't stop doing what you're doing if you feel good about what you're doing. Take a little corner and try some of the stuff in the corner. And if it's true, it should work. And if it works, it'll spread. That's how we've built this whole organization around the country, is not through media. We don't have a social media presence. We haven't done anything with journals and all that kind of stuff. We've simply been giving courses to farmers, and they've been trying it out, and they've been saying, holy crap, you guys got it. You guys tried this? So anyway, all right. Water, I just talked about water quickly. There was a guy named Kerry Reams, who people may not have heard of, one of the elders in this work. One of his foundational aphorisms was, if you cannot maintain hydration, don't waste your money on minerals. I'm going to talk about minerals after the break, and you're going to get all excited about taking a soil test. If you cannot maintain hydration, don't waste your money on minerals. That means it's a priority, if you've got a budget, to establish the environmental conditions where water can be maintained throughout the entire growing season, which is a different case for small gardens and vegetable plots than it is for pastures. So, I mean, the permaculturalists, I think, have a really wise perspective on organizing your land and the way you work your land around the water, and setting your water up first. I mean, anybody's heard about keyline? Anybody heard about keyline systems and the ponds? And there's some brilliant, really brilliant stuff that's been developed for basically passively watering your land. If you've got scale, if you've got grade, which you probably, it sounds like you got scale, you probably got grade, then you should be able to work with it and really keep and maintain hydration. I would say that would be a primary thing to be focusing on. But I use drip tape on my farm. I've got, at least where I've got beds, I've got, you know, what we call raised beds, which are basically a 4-foot top with a 1-foot wide divot. There's no boards, nothing, not raised beds. I didn't bring in stuff out of a truck that they call soil and put it in between boards. I just have a little divot, little trench every 4 feet. So when we get a hurricane, I don't get waterlogged soil. And then on that bed, I'll try a different color here. I've got 3 lines of drip tape in every bed. I want to maintain hydration across the entire soil profile. I want there to be no spot anywhere, pathway, edge of bed, top of bed, anywhere that I can stick my hand in the ground and find less than moisture. I understand that foundationally, when the biological system is functioning well, there's this web of life. There's this web, this network. People have heard about mycorrhizal fungi and all this kind of stuff. They don't do well when the soil's tilled up and bare and dry, right? You must have moisture, you must have cover, all these kinds of things. So for me, maintaining hydration is foundational. We had a 3-month drought last summer in Massachusetts where we got maybe a ½ inch of rain in 3 months. And people who didn't have irrigation systems went out of business. It was, quite foundationally destructive. So my farm, like I said, we do about 2.5 acres of vegetables. I have worked with the lay of the land, and I've seen where it's high here and low here, and I've dug holes in the ground. I rented a mini excavator This is my, 1 week a year I get to be a boy with big toys. And I rent a mini excavator and I go dig holes in the ground. And I've got 6 or 7 ponds now in various parts of my property, dug out where it's the low spot, and I just dug down 8, 10 feet, and I'm well into the water table, and I throw a sump pump in there. And a sump pump and the little, 300-gallon, UBC totes, that's my irrigation system. Sump pump to a tote at the top of the garden, and then that runs into the drip tape. Gravity feed drip tape. And I can maintain hydration with very low infrastructure cost in my 2 acres of production very, very readily. All I need is electricity to pump the sump pump in.
So you don't have a particulate problem in the drip tape. How are you filtering that? Because we always end up
Should
with
I
particulate
or am
problem
I?
in our pipes. We always end up with stuff in our pipes.
Yeah. I think if it was a bad enough particulate problem, I probably would have a filter, which I don't. And I probably should anyways, because
Well, you don't. I mean, you'd have a delivery problem pretty quickly if
I don't leave it in the mud at the bottom of the pond. I try to keep it. Yeah. So, anyways, irrigation is the point. Maintaining hydration is foundational. Nature does have systems for irrigating on a regular basis. I'm not sure if anybody's heard of the tidal force. Ever heard of the tidal force? Yes? Twice a day, water goes up and down. Ocean, something, moon. Apparently, the tidal force works on land also. Doesn't just work in the oceans. So as long as you don't have a plow pan, as long as you don't have a subsoil that's really totally compact, and as long as you've got a decent water table, your plants will be watered twice a day from below in nature. If you can take responsibility for your ecosystem, for keeping the water table high, dig your ponds as high in the land as possible, stockpile that water, address any underlying soil compaction you may have, you should not need to irrigate. But if you cannot maintain hydration, don't waste your money on minerals. Prioritize maintaining hydration. So there's all kinds of conversations about it and details and nuances. There's one question back there. Yes?
Yeah, well, 2 actually.
Shoot.
3-foot beds, 2 lines of drip tape enough?
Depends on your soil type. Basically, if the soil doesn't stay wet, it's not enough. Your hand should be, for me, there's all kinds of fancy sensors. I know about this. I've heard about them. I've never used one. I stick my hand in the ground and I see if I feel moisture. It's like, when you're making compost. Put your hand in there, pick up a handful of it. If it's too powdery to hold together, it's way too dry. You don't want it to get anywhere close to there.
And minimum spacing on the emitters, you're doing 6 inches everywhere.
I don't know. I get a roll of tape and throw it down.
You just randomly order
8-inch tape, 12-inch, 6-inch. If you've got a sandier soil, probably should be closer. If you've got a clayier soil, they should be farther apart. The obvious logical things, but yeah. All right, enough on water. I want to keep moving here before we run out of time to have a break and then a long enough section before lunch. You guys have winter sort of down here. Not really winter, but something resembling winter. Cold sets in, ground freezes, snow comes, stays for a while, ground thaws out about now. The last couple of weeks, ground thawed out. If there's areas where you had in the fall bare soil, now you'll find tight soil. Or not even soil because it's so tight, it's more like dirt. If there's areas in the fall that had mulch, you'll find now 6 inches of loose, aromatic, worm castings covered soil. My experience has been that when the soil is kept covered, the soil stays loose. I'm not sure if this has been anybody else's experience here. I like to say that the soil life is not able to go, at least from where we live. People go to Florida in the winter sometimes. Soil life is not able to hop in an airplane and go to Florida for the winter. Soil life is stuck there in the soil. And if they haven't stockpiled enough food in their root cellar, if their freezer's not full of meat, if they haven't dehydrated a bunch of peppers and eggplants, if they haven't canned their tomatoes and made their sauerkraut, if they don't have a stockpile of food for the winter, they're going to starve to death. And if it's the green leaves that are feeding them in the summertime, sugar, and there's no green leaves, then there better be some, stockpiled food, and generally that looks like organic matter, whether it's mulch or straw or, cover crops. So foundationally, my experience has been that when you keep the soil covered and therefore alive in the winter, it stays loose, and then you don't need to till it in the spring. I'm not sure if anybody else has had this experience of trying to plant seeds or seedlings into tight soil because they thought that being no-till was good, and their soil was really tight, and their plants didn't do very well. I think air is pretty important. Air, because most of the people who are living in the soil who feed the plant are aerobic, means they need air to breathe. If the soil's too tight, how far can you fit your hand down into the ground? Half an inch? 3/4 of an inch? Can you reach down 4, 5, 6 inches? Can you reach down 8 inches into your soil? As far down as you can reach is how far down you should expect there to be a decently aerobic environment. It's not a totally black and white, that's the line, but something along those lines. So
when you don't have that, do you feel like you need to till or dig it up, or so we've had a drought in this area, for the last, all last summer it was like hot and dry. Yeah. So the soil seems to get, compacted.
Quite.
So how do you remediate that? How do we get that fluff back in the soil?
If you don't keep it moist and you don't keep it covered, you can fluff it up, but it's going to fall right back down again. Right. So foundationally, changing your management practices to figure out how to keep your soil covered and keep it moist are systemic.
Still, even with a straw mulch on it, sometimes it will. If it's dry, it's going to compact.
So then water's your issue. So you need to figure out a way to maintain sufficient water. Once it has gotten compact, when we started our farm, we had an old rundown New England dairy. It was goldenrod and milkweed, in the fields and like low-growing brambles. It was not anybody's idea of a, nice, rich agricultural land. I dumped a bunch of minerals down there and tilled it right up, 5 or 6 passes to get down 3 inches. It was tight, hard, compacted, light-colored, no aroma, very few, very small earthworms soil. And I've got no problem with tilling up the soil, to convert it from one ecosystem to another. But the idea is that once if you can establish a good management practice, then you shouldn't need to till going forward, or you should be able to till very shallowly, minimally till, I'm not going to say categorically thou shalt not. Generally we understand it's counterproductive. I like to say if you haven't committed genocide recently and you want to know that by lunchtime you've been responsible for the death of a few 100 billion organisms, just take the tiller out for a quick spin and you should be comfortable after like 5 minutes knowing that you have been responsible for the death of 500 billion organisms. We understand this about tillage, right? We understand this about tillage. So we want to minimize it if possible, but we also want to establish the infrastructure where we are able to function as well. So I'm not going to say thou shalt not. I think depending on your scale, broad forks are a really nice tool. If you've got a garden scale, if you've got pastures, then the yeoman's plow, the rippers are really wonderful for cracking open subsoil. We understand about the forage radishes and the cover crops and all that kind of stuff. So I think a lot of the stuff you guys probably already are familiar with, the principles and the basic techniques. But I wanted to sort of tie together the food and the air and the structure and the system. Just talk about cover crops for a second. I saw a bunch of wonderful looking cover crops out here this morning. My thought about cover crops is that in many cases people have been told to put them in after they take their plants out. Anybody heard this one? Take your tomato plants out, take your squash out, and put your cover crops in. Generally, that involves a harrowing process or functionally a tillage process. Lots of work to take all your plants out of the field. Anybody do this? Take plants out of the field? I've heard of people doing this. They take plants out of the field, they put them in a pile, they turn the pile over a couple times, and they put all the plants right back onto the field. You heard about that one? No. Yeah. How much unnecessary effort is that? So what I propose is that you just take your cover crop seed and you broadcast it under your plants while they're still growing. Down here, it might be end of September, middle of September. I'm not sure when it would be. For us, end of August, beginning of September. Wait for a nice couple rainy days coming through. Hurricane, tropical storm, couple of days of thunderstorms, and broadcast your cover crop seed underneath your tomato plants, underneath your peppers and eggplants and chard and kale and squash and pole beans, There's no reason why you can't broadcast your cover crop seed underneath those things, get them established, get them to be 1.5 feet tall before the frost comes and kills your plants, right? I don't see any reason to, pull everything out, harrow things down. Like I see a beautiful transition opportunity here from one, summer crops to winter crops with almost no disturbance of the soil. I grew up on an organic farm where we did this thing called rotations. Anybody hear about this rotations thing? We would, religiously move our brassicas from plot to plot, and we'd, move the potatoes across the street, and the alliums would all get moved around. And we had to stop doing brassicas in the springtime because the flea beetles would take them out wherever we planted them. We would do cucumbers on 3-week successions because the powdery mildew would kill the cucumbers, and then we had a CSA, and the only way to keep cucumbers in was to put new cucumbers in every 3 weeks. We would move our potatoes across the street, 1/4 mile away, and they're up out of the ground by 1.5 inches, and the potato bugs were all over them. Anybody ever had this experience? I mean, what do they call it when you do the same thing over and over again and it doesn't work?
Definition of insanity.
Something. It's not being common sense or practical. If it didn't work 5 years in a row, 15 more years in a row of trying it is probably not going to make it work. From my perspective, the presence of the pathogen does not have anything to do, well, it has something to do, but I assume that the pathogens are everywhere. I assume that the powdery mildew is everywhere, that the late blight is everywhere, that the Colorado potato beetles are everywhere. I assume they're present in the environment. And running away from them and being afraid of them. You think you can take a plant that's got a fungal disease on it, and you can take the plant out of the garden, and that's going to remove the fungal disease? People know how spores work? You know how spores work? Right? As soon as they sporulate, they're everywhere. Hundreds of millions of spores off of one leaf of a diseased plant. Thinking that you can remove them from the environment, and then people do this. Anyways, I don't need to. No, I'd say let them fall where they are. Let them fall where they are is a short answer. Okay. Last 2 pieces of the puzzle here I want to talk about before the break. Life. Anybody heard of colostrum? Yeah. When you're born, right before you're born, there's nobody between your mouth and your rear end. The whole alimentary canal has nobody in it. Heard about this one? You also know you are unable to digest your food. We already said that this morning. And so the passage through the birth canal and the consumption of colostrum, that which comes out of the mother's breast after birth, before milk, are evolved to help establish flora on our surface and our other surface, our external surface and our internal surface, to establish that ecosystem of hundreds of different species working synergistically. We have designed grand design, some really basic practices for function. There's this thing called colicky babies. People may have heard of. Have you ever been into a dairy barn and there's a calf that didn't get its colostrum bawling? Anybody ever heard one of those? It's just like really, it's a little more shrill than that, but it's a really painful sound. This is nature's alarm system. This is nature saying something is really, really wrong. When babies cry, right? Anybody ever been in the presence of a crying baby? How long does it take to there is nothing in the world besides this that I need to deal with? Nature is telling you something's wrong. We have 4 children, and every time we have another one, people say, "You're not going to be sleeping for a year, huh, Dan? Har, har, har." I'm like, that's not been my experience. My experience is that they nurse and then they sleep, and then they occasionally wake up and pee and gurgle at you and poop and nurse some more and sleep. Crying is a very irregular occurrence caused by something specific and oftentimes very short-lived. I suggest that we have sort of assumed this colicky babies. Babies are going to cry. They're going to be in pain. They're going to be, we assume this, but we don't understand that foundationally colic is a poorly established gut flora. Right? You are not able. The people inside of you have not set up shop well for you to digest your food. It's a really rudimentary thing. And for plants, it's remarkably similar. Plants are unable to digest their food. They need a well-established gut flora at birth. They need their colostrum. They need a full spectrum of species of bacteria and fungi to be present on their root surface when they germinate for them to be able to flourish. Otherwise, they're going to be colicky babies. They're going to be damping off. They're going to be, weak. They're going to have all these other systemic issues that occur. So this is the easiest, most rapid, least expensive thing I'm going to be suggesting through the entire 2 days is inoculating your seed. I think it's really, really foundational. I will talk more about it after lunch, but establishing good gut flora and maintaining good gut flora is critical. All right, final topic here is minerals, which is my topic for after the break. So maybe we can just jump into it then. Yes, sir.
I just had a point when you were talking about air. I've been battling bowls.
Yeah.
And last year I had the best fruit season I've ever had.
Yeah.
And when I was digging around in the soil, I noticed that the roots had taken to the bowl tunnels.
Yep.
And it was like they basically just, had the air in there, and they did real well. Even, because the bowls only eat certain roots, but they tunnel everywhere.
Yeah.
And I just wanted to make that point about how important the air is in the soil.
It's really, it's one of those things no one ever told me about.
Yeah.
No one ever told me anything about air. It was just, I know how to transplant, I know how to seed, I know how to weed, I know how to pick, I know how to mulch, I know how to do all kinds of things, but no one ever taught me about, it's about the soil life feeding the plants and they need air to breathe. I never thought about it. It's one of those most rudimentary, most powerful, you can't sell a product, I guess you probably could, but yeah. A lot of these things are, yeah.
So one of the interesting things they've started to find more and more is we're talking about that lunar tide coming up and down. It's actually part of the lung function of the soil. As the water rises, it pushes the air up out of the soil, and then as it falls, it's pulling fresh air back in. So it's like pulls it back in. So it's like the lung function of the soil is that rising and falling water table.
Yeah, it's beautiful how all these things fit together, and we never thought about it. It's just so amazing when you begin to see how it's all connected. It's beautiful. Yeah. Somebody brought up this heavy feeder point during the break. Heavy feeder, I think it means likes lots of nitrogen. Is that what you guys think it means? Yeah. I don't know what heavy feeder and what's not a heavy feeder. In the olden days, before God invented fertilizer, who was adding nitrogen to all the non-leguminous plants? Every single plant in nature has the capacity to fix nitrogen through symbiotic relationships with bacteria and fungi. Every single plant for a very long time was getting its nitrogen needs met through healthy leaf life and healthy root life. We think we have to add fertilizer only because when we don't add nitrogen, in some people's cases, they don't add nitrogen, things don't do as well. Well, how do you define well? It's a whole long conversation, but my understanding is that you only need to add nitrogen when the system of harvesting nitrogen is broken. 78% of the atmosphere is nitrogen. People heard this one? Yes. 78%, right? More than 3/4 of every breath of air you breathe is nitrogen. You should not need to add nitrogen to your soil. You should not need to add nitrogen to your plants. You only need to when they are unable to do what they have evolved to be able to do. So I personally don't use compost on my farm. I don't use nitrogen sources. I don't use blood. I don't use fish. I don't use any of that stuff. I don't think I consider it to be like, that's my new dogma, I guess, there's a couple things. Like, I don't kill insects. I refuse to kill an insect. I refuse to kill a disease. And I refuse to add nitrogen. These are just a couple of things that I do. So we can talk more about it later if you want. That was just a minor point that came up. And rotations, there was a question about rotations and whether I rotate my crops. And that's probably the only thing that I do that would make me not certifiably organic, is that I don't keep track of where things were and follow a rotation schedule. I don't particularly care. Some years will put kale plants right back into the holes where the kale plants were from last year. I try to do polycultures as much as possible. So I've got, cucumbers on this over here, and pole beans over here, and tomatoes in the middle, or salad greens going to seed next to the peppers and eggplants. And I like to have a polyculture as much as I can. And how do you track rotations on a polyculture? It's just ridiculous. So I don't bother. And I'm not sure what the answer is. If you were a baby rabbit, just born, would it be appropriate to be given colostrum from a cow?
It wouldn't work very well.
If you were a radish seed, would it be appropriate to be put into soil where the microbiology of onions is dominant? It doesn't seem to make sense to me. Doesn't seem logical that you would have where the brassica people were hanging out last year and they established a gut flora in the soil of brassica dominance, of brassica gut flora. Why would you put tomato plants in there?
On the other hand, if you're keeping a polyculture going, then none of that soil is really specific to one species. It's specific to a bunch of species.
Well, the broader the spectrum of species, the broader the species in the soil. So I think, I started out saying we need to think about agriculture as it was done 500 years ago as what we should be aiming towards. And a lot of the, ways our heads are in a box is with these assumptions of tillage and of monocultures and of bare soil and of fertilizer. We need to sort of conceive of reality outside of the box so we can establish a path for moving forward. I think a lot of these concepts we're fixed with because we're starting with certain basic assumptions. So I made that point. I don't need to spend too much time on it. I want to talk about minerals now. I'm going to try to go fast on this one. I got a lot of things to say. And I'd like to be able to have you guys, by lunchtime, able to read that soil report and make your own recommendations off of it. It's not that difficult of a project. But before we go there, a couple foundational points. So about the critical role of elements, this is one of the pieces of the puzzle that I never learned about. As an organic person in the 80s and 90s and early 2000s, no one ever was talking about these things in the world I traveled in, at the conferences and the newsletters and things like that. So maybe that's different down here. But this is one of the things that I learned and started experimenting with and started seeing, looks like this stuff works. I'm not quite sure because how do you know? But so I want to talk about it for a second. For starters, before I get into it, or I will just start with a couple minor points. Anybody here ever been a vegetarian or a vegan? Heard about such things? Yes, it used to be cool. It's not quite so cool now. I mean, I remember there was a time when it was like anybody was cool as a vegetarian. Yeah, I was going to go with the 80s. Yeah, that's what it was. Back when nobody knew what granola or yogurt were. Yeah. So my understanding is that if you're a vegetarian or a vegan and you go to a doctor, sometimes they'll tell you that you're not getting enough vitamin B12 from your plant-based diet. You have to supplement with vitamin B12. Vitamin B12 is the common name for a compound that's referred to in science as cyanocobalamin. Cyanocobalamin, it doesn't really matter. The cobalt part is what I'm wanting to drive at. Vitamin B12 is a compound with one atom of cobalt in the middle. It's a cobalt-based compound. The amino acids and things that are attached and the carbon chains that are attached to the cobalt are not in short supply. It's the cobalt that's in short supply. If you don't have enough vitamin B12, you become anemic, which means you become weak, lethargic, low energy. If you really don't have enough vitamin B12, you become dead. Right? We are vitamin B12 dependent organisms. We need a certain amount to live, and if we don't have it, we become dead. And it's really the cobalt in the middle of it that's the limiting factor. So we can say we're a cobalt-dependent organism. We need a certain amount of cobalt in our bodies to function. Interestingly, 80% of the species of soil life that have been studied are also B12-dependent organisms. 80% of the 4.5 million species of soil life are B12 dependent. You can add compost all you want. You can add compost tea, you can inoculate, but if you don't have some of these critical elements present in the ecosystem for them to function, they're going to die. People may have heard of bean and pea inoculant. Anybody heard of bean and pea inoculant? You buy a little inoculant with azotobacter and rhizobacter, and you put it in with your bean and pea seeds so that they can, fix nitrogen in their nodules, and you feel really proud of yourself. So anybody, this is just a fact. There are 1 million pounds of the element molybdenum sold mixed into bean and pea inoculant every year in this country. Molybdenum, which maybe some people have heard about, it's an element like copper and zinc and iodine and yttrium and vanadium. 1 million pounds of it are mixed into bean and pea inoculant and sold every year in this country. Do you know why? The nitrogenase enzyme. The nitrogenase enzyme is the tool that's used by the azotobacter and the rhizobacter to pull nitrogen out of the atmosphere. You can have, just because you have the azotobacter and the rhizobacter does not mean you get the nitrogen fixation. You need the enzyme, this is biochemistry, you need the enzyme to do the job, and the enzyme is a molybdenum-based enzyme. 1 pound of molybdenum in an acre is all you need for all of the nitrogen fixers to fix nitrogen for all of the plants. Molybdenum is an anion, which means it tends to leach. The more the soil's been tilled, the more it rains. Historically, last time you guys got glaciation was a little while ago. So if you don't have enough molybdenum in the soil, then your nitrogen fixation can't occur, and then you have to add nitrogen.
How do you spell that word?
M-O-L-Y-B-D. So the point I want to make here is for life to function well, there's actually a broad spectrum of elements necessary. And this is something that I never learned about. And as I've started to experiment with it, I've been seeing some pretty exciting results. And so I think somebody asked a question about Elaine Ingham. He's not here right now. It's Pat. Yeah, I'll answer that. Next time when he comes back in, I'll bring that one up. Okay. I was hanging out at her research farm in the Sierra Nevadas. Was it yesterday? No, day before yesterday. Talking shop. We got her roped into our big project on the Gizmo. She's all bought in, making introductions. Okay, so just a couple points there. Molybdenum and cobalt, never heard of them maybe, never thought about them, never understood them. We'll get into more biochemistry and talk about what enzymes are and how they work by tomorrow, if not later today. It's not that complicated really if you understand the basic principles. But before I go into all that, I wanted to start with some basic sort of concepts in agriculture. In the Western culture, we say that agriculture started around 10,000 years ago. People may have heard this story. Mesopotamia, Tigris and Euphrates, hunter-gatherers, something, collecting grain, started planting grain, started building permanent houses, started having cities and hierarchies, and culture began because of agriculture. You've heard this one? Right, we can rip that one apart, but we'll just let that stand as like, this is the dominant story. All right. Agriculture has been practiced in many places around the planet, and we have, in the last 10,000 years, and we have many examples of places where there used to be a flourishing culture, and now there's a desert with some ruins. I mean, you can think about examples of that in your mind. There's this place in Syria called Palmyra, which is constantly being taken over back and forth by the Syrian government and ISIS right now. It's called the Desert City, Palmyra, the Desert City. It's a 2,000-year-old city. There's this ancient, beautiful art in it, and whenever ISIS gets it, they blow up some more stuff. It's 200 miles this way is desert, 150 miles that way is desert, 100 miles that way. It is a city in the middle of the desert. I'd like to, ask one basic question: whose brilliant idea was it to build a city in the middle of the desert? And the answer is, it wasn't a desert when they built the city. When they built the city, it was a fertile, fecund plain, and they practiced agriculture and failed. The practice of agriculture in many places has worn out the land. We can see systemically that this is a pattern. There are a few places where the practice of agriculture has not worn out the land. There's a few places where they've been practicing agriculture in the same spot for thousands of years and with big cultures. I direct you to the Nile River Valley, the Indus and Ganges River valleys, the Yangtze and Yellow River valleys. There's still Mesopotamia, Tigris and Euphrates. There's ancient cultures in these river valleys that are still doing agriculture in the same spots when they're not in other areas. And I'd like to suggest a possible reason why, and that is because of what comes down the rivers. Just before we go into that, if you were a wheat plant, it is foundational in your life to give your babies the best options for their life. And so my understanding is that plants in general, whether it's tomato plants or cucumbers or apples or whatever, basically isolate the most valuable nutrients that they possibly can to put into their seeds so the next generation has the best chance. If you are a farmer and you are systemically harvesting all those nutrients in those seeds and removing them from the land and eating them and pooping them out somewhere else, then functionally agriculture is a mining process. 20,000 pounds of crop per year, maybe 18,000 pounds of it are air and water, but there are 2,000 pounds of actual minerals that are being mined out of the ground. And it's not just calcium and potassium, it's also cobalt and molybdenum and selenium and vanadium and copper and zinc. And at some point with tillage, with rain, with anions, leaching and things like that, you begin to get limiting factors. You begin to get certain things that are necessary that are no longer present, and so the whole system collapses. Does that make sense in some kind of rudimentary way? What happens in the Nile River Valley, there's actually a Blue Nile and a White Nile. People may have heard of the Blue Nile and the White Nile. The White Nile comes out of the mountains, I think Ethiopia. The glaciers, there's still a couple of glaciers left, grinding up the mountain. And it's called the White Nile because the glacial milk, the finely ground rock dust, causes the water to be white. The Blue Nile comes out of the Congo, which is an amazing tropical rainforest like the Amazon. So you get all this organic matter and life. That's why it's blue, it's dark. So you get the White Nile with the minerals and the Blue Nile with the organic matter and life, and you mix them up and you dump them on the ground every year in the floods. I'd say that's an amazing fertility program. I'd say that is a rock star level fertility program. I don't think we need anything more than crushed up rock to systemically remineralize our land. I don't think we need fertilizer and all that kind of stuff. But in many cases where land is denuded, I think systemically remineralizing it is not a bad idea. So I'm going to be talking more about the specific things that you can buy in bags, like limestone and rock phosphate and copper sulfate and things like that, and borax, to talk about specific elements in the next half an hour when I talk about this whole mineral balancing thing. But more broadly, I think from a systemic standpoint, between finely ground rock dust and seawater, we have all of the minerals we need to revitalize this planet in very short order. We'll talk about the mineral balancing and the details, but then we can go back to rock dust and all that kind of stuff later if you'd like. So that's one point. Other point is a guy named Dr. William Albrecht. It's the Albrecht style soil report, soil test that I'm going to teach you how to make recommendations from. And I just want to give you a little bit of backstory on Albrecht. He was a farm boy, grew up in Illinois. He went to university to study agriculture, was a good student, went on to get his master's and his PhD. He did his graduate level research looking at overlays between World War I draft records and soil types. So he found a really interesting connection between the soil type where draftees were brought up and their rates of acceptance for the draft. Boys that were brought up in Appalachia were accepted at much lower rates than boys that were brought up in the upper Midwest. The regulations for whether you were accepted for the draft or not in World War I were set after the Civil War. In the Civil War, if you couldn't march 20 miles and eat hardtack, then you were more of a hassle than you were worth. So if you had flat feet or bad teeth, you were not accepted. In World War I, for trench warfare and gassing and things. But you know how the military is always a little behind in their regs. You don't need to march 20 miles to sit in a trench and get gassed. But anyway, The point is, there were some major physiological differences in the humans based on the soil type they grew up in. And it wasn't that all the Germans were in one spot and all the Italians were somewhere else, right? There were people of the same genetic lineages living in different areas showing these common disparities. And Albrecht said, that's very interesting. This was before food got shipped all over the country. This is when people mostly ate food that was grown locally. And so the thesis was that there's a connection between what's in your food and what's in the soil and how your body develops. And so Albrecht set about doing a bunch of research, I think over 500 published papers. He was the chair of the University of Missouri Soil Department for 20 years, land-grant University Soil Department chair for 20 years, formal, legitimate, Western science, land-grant university agronomist, right? This is not some podunk, hokey, philosopher. This is a hard scientist dude. He took the clay and put it into a centrifuge, spun it out, spun all the, the cations that were attached to it, the copper and the zinc and calcium and potassium, spun them all out. He put minerals back in at different levels. He would put 50% calcium and 20% magnesium and 10% potassium here, 60% calcium, 20% magnesium, 10% potassium there. And he grew out crops in those different soils and then fed them to animals. Fed them to rabbits, fed them to rats, fed them to chickens, fed them to pigs. And he was able, in 2 generations, to get animals that these guys over here had larger litters, longer lifespans, more cuddly and friendly. These guys over here, smaller litters, shorter lifespans, more aggressive. He was able to get major physiological variances in the animals based on what was in the soil that their food was grown in. Really, 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 really interesting stuff that was being done by the land-grant universities in the 30s and 40s. So I'm going to teach you how to read a soil test based on the Albrecht principles. It does seem that there are some critical environmental conditions necessary for life to function across the board, and it's really not crop specific or even kingdom specific. There's some really critical environmental conditions necessary for life to function in general. Anybody ever read a bag of chicken grain label on a bag of chicken grain? You see after the first 5 ingredients of the types of grain it is, there's like 4-8 lines of long, complicated sounding vitamins and herbs, like whatever. Copper and zinc and boron and manganese, all these different trace elements are in these vitamins which are added to the grain because guess what? They did the science and they figured out that if you don't have these critical elements present, your animals don't grow and you don't make money as a farmer. They figured this out a long time ago. You look at the ingredients in Miracle-Gro and you're going to see 15, 16, 17 different elements because the science is there. We know that plants need a broad spectrum of elements to flourish, and Miracle-Gro has a business model which says we want our crops to flourish, so we're going to give them a full spectrum of nutrients. If you look at a multivitamin, you'll see that full spectrum of 15, 16, 17 different elements that you do not see in a normal soil test. Most soil tests will give you recommendations for 3 elements: nitrogen, potassium, and phosphorus, which are great if you want to jack up your plant on steroids and get them to grow real fast and real weak and be susceptible to infestation, but they're not great if you actually want them to be healthy and functioning well in the ecosystem. So my argument is if we can identify the minerals that are deficient in the soil and address them as systemically and inexpensively and locally as possible, this should be a short process, like a couple of years, to rebalance your soils, at which point you shouldn't need to be adding things thereafter. Right? Nature's not bringing in stuff for things to flourish. I don't think we want a, what's the word, sustainable? We don't want to sustain weakness and sickness, right? So we don't want a sustainable system in our gardens. We want a regenerative system in our gardens. So I would say we spend a couple of years identifying deficiencies, get them addressed, and then you can maintain at that level of high function for quite some time. Right? We need to, we can use our science and we can use all that stuff systemically if we want to. So anyway, those are a couple thoughts about rationales for mineral amendments. The B12, the nitrogenase enzyme, the rivers and ancient cultures and desertification and Albrecht. I would be happy if anybody wants to check my citations on any of that. I think it's all kind of self-evident when you put it together in your mind, and it's just one of those things that we haven't had presented to us.